So students, we are in the chapter force and we come to the topic pressure. So to understand pressure, first try to understand what is thrust. Suppose I apply a force on this board. Then you see the force is not directed at right angle. Or I can tell you this way, if I apply a force through this stick on this box, then it is not at right angle. But if I apply the force like this, then the force is acting normally. See, in maths, normal means perpendicular. So it is acting normally. So the force acting normally is called thrust. So the unit of force is Newton. So the unit of thrust will be also Newton. That is the first thing you have to understand. The thrust is also force. Thrust is perpendicular force. Thrust is perpendicular force acting on a body. Like if it is at right angle, then it is perpendicular force. If I am applying a force like this, then it is a perpendicular force. So force acting on a body perpendicularly is called thrust. And then pressure is the thrust acting per unit area. So pressure will be thrust by area. Now we first do numerical calculation. Two numerical calculation we do. What is the pressure? What is the pressure? The pressure if a 50 Newton of force means thrust is applied on an area of 5 meter square. B 50 Newton of force is applied on an area of 10 meter square. So straight away what we do, we solve these numerical, then the concept, sometimes physics concept are to be understood by numericals. Sometimes physics concepts are to be understood by through numericals. So I write pressure, okay, I will change I write pressure is equal to thrust perpendicular force by area. So in the first case, for A it will be 50 by 5, that is 10 newtons per meter square, that is equal to 10 Pascal. So SI unit is Newton per meter square or Pascal. SI unit of pressure is Newton per meter square or Pascal, so 10 Pascal. Now question number B. Okay, question number B, let us see. Pressure is equal to force by area. So it is 50 by 10. So it will be 5 Newton per meter square, that is 5 Pascal. So now you see, I am keeping the thrust constant both the places, 50 Newton and 50 Newton. But area in the first one is 5, then pressure is 10. And in the second, area has increased double, 5 to 10. Then the pressure is decreased. So what do we see? Pressure depends actually on two factors, thrust and area. So thrust is on the numerator. So when the numerator will increase and if I keep the denominator fixed, then the pressure will increase. We can take up another one that we change this time. This time we change suppose here, now try to understand. Here I take this sum, 50 Newton acting on 10 meter per square. So 50 Newton acting in an area of 10 meter square is 5 Pascal. Suppose I say 100 Newton acting on 10, and then it will become 10 Pascal. That means if I keep the area fixed and increase the thrust, then pressure is directly proportional to the thrust and inversely proportional to the area. Inversely proportional means what? If area increases, see it has increased 5 to 10, pressure will decrease, it has decreased from 10 to 5. So that is why pressure depends on two factors, thrust and area. This will be now practically explained to you. Try to understand. Suppose I have to cut this potato. So I am using this stick. I am trying my best, nothing is happening. But now I am taking a knife. So see, the knife has got, the edge of the knife has got very less area. So now what will happen? See, now you get the potato cut. So that means what has happened? Knife has got very less area and therefore pressure increases, and so we are able to cut through the vegetables or whatever we are using. So there are a lot of practical application, but one very important numerical concept and the concept on application of pressure on gadgets made or use of this is there in many places. You know what happens? Suppose somebody is sinking in a muddy, in mud, say for example, then he should lie down. His weight will be the thrust. So suppose my weight is 50 Newton and the area of my feet on the mud is 1 meter square. So the pressure applied will be 50 by 1. That is too much. So straight away I will sink. 50 by 1 is 50 pascals. But if I lie down and suppose my area is now 10 meter square, so 50 by 10 will be 5 pascals. So when we are sinking in some some fluid, it's better to lie down. You may be applying less pressure. Secondly is, you see, normally the truck carries a lot of weight at the back because things are loaded at the back. So the trucks will have 2 tires each. That means totally 4 tires at the rear side. The front will have one tire and the back will have 2 tires. That is to support the weight. So a lot of thrust is acting downward. So they have increased the area by doubling the tire on each side. Buildings are made, then the foundations, under the ground, there is a large foundation. Under the ground there is a large foundation. Very large foundation. This is below the ground. And then from here you take up the the pilings up. Then the base is very base has got large area. So base has got large area. Therefore this pillar, if it is applying pressure, everything is everything is, the pressure has decreased. So the beam is now being supported well by the earth. It does not sink down. So those are the things. Knives, I already said, knives have sharp edges. When you have to hammer a nail inside the wall, then the pointed end should be facing to go in, because it has got minimum area, so maximum pressure will be there. So that is very important concept for you. Many of the times you see in circus, they show that the elephant crosses a person. But you see, the elephant, when it is crossing, what they do, it is not the elephant is putting his feet right on the stomach of the performer. They will keep a very flat and big, plyboard. So the elephant, when it is putting the weight, the pressure is being distributed in that much of area, and therefore the performer is experiencing less pressure. But that you don't have to do. Thank you.